So today's our last topic in college algebra. Super excited. I'll be honest with you, there's no separate test or quiz on this topic. Today I teach it to you. Tomorrow is a practice day. So if you're not going to be here tomorrow, I can get you your practice work. I should let you know that there are a couple of questions about this topic on your final exam. So how are you assessed on this skill? A little bit of book work tonight, a little bit of practice in class tomorrow, and then it pops up on your final exam. More important than this being a college algebra topic, it's more about setting you up successfully for trig. So for those of you that are hanging out with me in the second semester, this is more of what we do. So I wanted to just kind of let you know that this is really important foundational groundwork for those of you hanging out with me next semester. With that being said, I just wanted to take some time reviewing completing the square because it's going to play a super important role in your success today, tomorrow, and then with these types of problems on the final exam. So let's take a look at number one. I'm going to do that one with you because there's fractions in it. And then number two, the numbers are a little messier, but there's not fractions. So I'm going to let you do number two. Completing the square is, in my personal opinion, the worst way to solve a quadratic equation because it's long. Like if you look at number one, x squared plus 5x plus 4 equals 0, that's factorable. Like you could look at that. Factors of 4 that make 5 are 1 and 4. So our answers to this problem, I just did it in my head. -1 and -4 are the numbers that would satisfy that particular statement. So completing the square, I wouldn't even bother doing on this problem. But because the numbers work out nice, I chose this one to kind of review that skill. Step one in completing the square, I don't know if you remember it. Step one in completing the square makes us do something with this number right here, that 4. Do you remember what we have to do first? This is another reason why I like this topic, because completing the square is on your final. So it kind of like helps us review some other prerequisite stuff that we haven't done in a while. Hallie. Yeah, you have to move the constant to the other side of the equal sign. That is the first step in successfully completing the square. Good, Hallie. So I would subtract 4 from both sides. And then do you see how there's this like weird space kind of hanging out now in the middle of my equation? There's a little formula for the number that goes in that space. Does anybody remember what that formula is? I know you're all like, oh, has a B in it. Jen.
B over 2.
So close. So good, Jen. B over 2. Squared. Thanks, Dylan. He's like, squared. Yes, indeed. It is B over 2 squared. So B in this case is 5. I'm going to take B, which is 5, divide it by 2, and then square it. That gets me that number that goes in the blank. 5 divided by 2 squared, square the top, square the bottom. That is 25 over 4. What you do to one side of an equal sign, you must also do to the other. So I have to add 25 over 4 to the right side of my equal sign as well. Everybody okay so far? Okay, so this is where it gets dodgy because you have to factor the left side and simplify the right side. Factoring the left side when you have fractions in the equation can be tricky, but I did show you a little bit of a shortcut. What we're trying to do is fill in right now a set of parentheses. And in that parentheses goes the factors of x squared plus 5x plus 25 over 4. Well, if you don't want to try to sit there and think about the numbers that multiply to 25 over 4, but then add to 5, you could just steal this b over 2 value, including its sign, and plop that right next to your x. A little shortcut for you. If you remember that, kudos to you. Now, if you did FOIL, x plus 5 over 2 times x plus 5 over 2, the last 5 over 2 times 5 over 2 would give you the 25 over 4. And then 5 halves and 5 halves that's 5. 2.5 and 2.5, that's 5. So that's how you would get that number right there. So it does actually work. Okay, on the right side of the equal sign, I need to simplify this. You folks might remember from your test yesterday that you can't add or subtract fractions when your denominators aren't the same. So first I need to get an LCD. The LCD between 1 and 4 is 4. So negative 4 over 1 actually becomes negative 16 over 4. And there's 25 over 4. And then still simplifying that right side of the equal sign there, I would add those two things together. Negative 16 fourths and 25 fourths is 9 fourths. And now I SADMAP. So I'm going to square root both sides. And I have x plus 5 over 2 equals plus or minus. And whenever you square root 9 fourths, you have to square root the top, square root the bottom. So this will be 3 over 2. To solve for x, I need to subtract 5 over 2 from both sides. Balancing the left side of the equation, I get x by itself. And then what I do to the left side, I have to do the right side. This actually gets me 2 little math problems to work out. I have to do the case where we do positive 3 over 2 minus 5 halves. And then I have to do the case where I do negative 3 over 2 minus 5 halves. So I have to take care of both of those. When I go to evaluate those, 3 over 2 minus 5 over 2, that's negative 2 over 2. So you see, I get negative 1, which we had anticipated at the beginning. And then negative 3 over 2 minus 5 over 2, that's negative 8 over 2, which is negative 4. So that's how you complete the square. And obviously for this problem, if this were a question on your final, you should totally factor it if you get the choice. Completing the square on this one, seems like a big waste of time, but it is a good problem just to show you how the process works, just to review all the steps. I'm going to let you try that second one, and then while you try that second one, I needed to collect 2 things from you today. So I'm going to, all right, so what you need to understand is what are the pieces of this equation. Like I said, this is an equation of a circle when it's written in what we call standard form. All in all, we're going to talk about 2 forms for an equation of a circle today. This one is called standard form. And what's nice about standard form is that it's super easy to pick out the center of the circle and the radius of the circle. The center of your circle actually comes from those 2 letters right there. Keep in mind, they're the letters next to minus signs. If these signs change to a plus, we have to do something else. So to calculate the center of your circle, quite frankly, you just pull the numbers next to the minus signs. So H would be the x coordinate of your center, and then K is the y coordinate of your center. All circles have a common center point by definition. So by definition, a circle is just the infinite set of points that are equidistant from one center point. So that's, your center is going to be HK. The other points are going to be the length of the radius away from the center. So how do you calculate the radius? You look at that guy right there. R, oh, this is funny. I'm going to tell you the story from my period 2 class. I was like, you're all smart people. We're talking about circles today. What does R stand for? Okay, what are you going to say? Yeah. Okay, seriously, I heard round in my second period class. I was like, oh yeah, true. I hadn't thought about that. But it's so funny. I like died. I died. I think it was Tommy White, if you know him. I'm totally ratting him out. Yeah, I like died. So R is the radius squared. So if you wanted to calculate the actual radius, you actually have to end up square rooting that number on the right side. All right, so we start the lesson today using this formula to initially just write the equation of a circle. So when I look at example 1 right here, it says write the standard form of the equation of a circle with the following criteria. So what they're telling me here is my radius is 5. Right away, I know that r in my equation has to be 5. The center that they give you is always your h and your k value. So I could take my form of my equation, x minus h squared, plus y minus k squared equals r squared. And I can plug in what I know about h, k, and r, simplify what's there, and then I'm done. So I'm going to go ahead and fill in what I know about h. So x minus h. H in this case is -3. Squared plus y minus my k value. Well, my k value in this case is 6. So I'll fill that in. And then r, they also gave me that. R is 5. So if I do r squared, that's going to be 5 squared. We don't leave it looking like this. We have to simplify this expression a little bit. For instance, the big kids don't write x minus a -3. They write that as x plus 3. And then that'll be squared. Y minus 6, that's simplified in that quantity there. And then 5 squared, we'd write that as 25. So that, congratulate yourself, you just wrote your first equation for a circle. Questions about that? All right, let's do it again. So part B, you see the r value there? It is 2. And they're telling you h is going to be 0 and k is going to be 0. So if you have the formula on your formula sheet for the final, it's just a matter of plug and chug. So I would do x minus h, which was 0, square it up, plus y minus k, which is 0, square it up. And then that has to be equal to the radius squared, so that'll be 2 squared. The big kids wouldn't leave something looking like this. They would simplify it a little bit. X minus 0, that's just x squared, plus y minus 0, that's y squared, and then that's equal to 2 squared, which is 4. So you see, if you have a standard equation of a circle and there's nothing next to your x or your y, your h and your k value is actually 0. Questions about that? All right. Now we have to use this information to produce a graph of a circle. And I know a lot of you don't like graphing, but this you will love. Okay, check it out. So the first thing that you need to keep in mind is to graph a circle, you have to graph its center and its radius. So if you look at this right here in part A, we have the quantity of x plus 3 squared plus the quantity of y minus 2 squared equals 16. I could look at this pretty quickly and determine what my h and my k value are. I could figure out my center point. Careful though, remember I said h and k have to be next to minus signs. So if I look at x plus 3, I kind of have to go backwards in my head for a second. X plus 3 is the same as x minus a -3. Do you see that? So the h value for this center, if your center is the point h comma k, the h value in this problem is actually -3. The signs are what throws people off in this lesson. If you can iron that out for yourself today, you're doing pretty good. Does everybody see why that h value is -3? Because it was next to a plus sign in the parentheses. Okay. Then, remember your k value is also the value next to the minus sign on the right. Well, this is just next to a minus sign, so k is just 2. So you would start by plotting your center. And I'm going to plot the point -3, 2. So you go to the left 3, up 2, put your center. A circle also has to have a radius, right? Well, we know that the value of r squared is 16. So if I want to calculate the radius, and I know that r squared is 16, I just need to square root both sides. So my r value in this case is actually 4. What you need to come to understand, if you're going to hang out with me in trig, is that a radius is just a distance between a center and an outside point. Distance, my people, always positive. So I don't have to worry about plus or minus when I'm calculating a radius. Radius is always positive. So I just need to count out 4 units from my center. So to plot the actual circle itself, I just say grab 4 points. Go, in this case, we're going to go north 4 or up 4, down 4, to the right 4, and to the left 4. And then you just connect those 4 dots. So I go north, south, east, and west, the length of my radius. So I'm going to go up 1, 2, 3, 4. To the left, 1, 2, 3, 4. Down, 1, 2, 3, 4. And to the right, 1, 2, 3, 4. And I connect the dots. And because I made this graph paper and it's probably not a perfect square, my circles often look like Stewie's head from Family Guy. When I go to draw it out, it's all right. I'll try. Still can't really draw a circle. Mr. Cummings, also, fun fact, cannot draw a circle. Geometry, you call him Dr. Geometry. Can't draw a circle. It's always like wonky. All right. Let's do it again. Make sure you understand it. So in part B, again, the idea is to pick out your center and then your radius. So your center is your h and your k value. And in this case, like I said, watch out for it. There's no number next to your x value, so that means that our h value is actually 0. So I didn't subtract anything from my x. I subtracted nothing, so my h value is actually nothing, or 0. And then my k value, again, always next to the minus sign on the right, and this is just next to, a 1 is just next to my minus, so my center is actually the point 0, 1. So I'd plot that point first. And then to find my radius, what I'm observing right now is the fact that r squared is 9 in my equation. So if I want to square root both sides, I get an r value of 3. And then we have to go to finish plotting the circle, up 3, down 3, to the right 3, and to the left 3. So way easier than graphing a rational equation, yes? Yeah. Okay. So, and then tomorrow, we'll be practicing this. All right. Not quite done yet, because as promised, there are 2 forms that the equation of a circle comes in. This is what we call general form. Kind of looks like a polynomial. You have a bunch of terms here, x's and y's in them, usually a constant term. It's kind of useless as it stands. Like, you look at this, and the cue that I know that this is actually an equation of a circle is the fact that there's x's and y's in it, and those are both squared. So I know, in my experience, that when I see x squared and y squared, that's a circle. But as it stands now, that's all I know about this shape. What we're going to be asked to do here in example 3 is write this equation in standard form. And here's why. Ultimately, we're responsible for determining the center and the radius of the circle. Well, if we want to find the circle's radius or radii and its center, this equation is useless. So I have to turn it back into the other equation, and then I could pick out the h, the k, and the r. So they tell you this step here, but I have to do that if I want to figure out what h, k, and r are. So let's do that. This is where that warm-up comes in, completing the square. So let me show you how it works out. It's actually pretty neat, pretty slick. We're going to turn this back into x minus h squared plus y minus k squared equals r squared. The first thing we would want to do, if you notice that all of our other equations, do you see how all of the x's are grouped together and then the y's are grouped together? and then the constants on the other side, I want to start to get this hot mess of an equation to look like that. So I'm going to group my x's together, group my y's together, and move my constants to the other side. So those are my x terms. I'm going to group those together, leave a space. I'm going to group my y's together, leave a space. So that was me putting my y's together. And then do you see this plus 12 right here? I'm going to move that to the other side of the equal sign by subtracting it from both sides. So that's equal to negative 12. Curious, we left a blank in the other warm-up questions too, right? There's a formula for what goes in that blank. This is where completing the square comes in. What is it, Kayla? Yeah, very good. So we're going to take our b value, cut it in half, and square it. We're going to add it in right there. 4 divided by 2 is 2. 2 squared is 4. And I know you're sitting there probably saying, why would I do this? Hold on, you're going to see. It's like awesome. Okay, then I have to do it over here too. So I have to take negative 6, cut it in half, and square it, and that gets me that number that goes in that blank right there. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Keep in mind, what you add to one side of an equal sign, you must also add to the other. So I added a 4 on the left side, and I added a 9. So I also have to do it to the right, or else I violated that addition property of equality. Can't do that. Those trinomials are now both factorable. Watch what happens when I factor them. So factors of 4 that make 4 are 2 and 2, right? So that'd be x plus 2 times x plus 2, or x plus 2 squared. Bring down my plus. Factors of 9 that make negative 6 are negative 3 and negative 3. So I'd do y minus 3, y minus 3, or y minus 3 squared. Look at how it looks. It's like looking like it's supposed to. All right. And then negative 12 plus 13 is 1. Poof! Magic. Standard form of a circle. Just like that. I think it's so slick when stuff comes together like that. I don't know. This is why I'm a math teacher. Ready to have a good time. All right. What? Yeah. When you get into it. All right. This is not my only mission here. Why I did this is because now I can really clearly see the center of the circle and its radius. So the center, remember, is your h comma k. So h, remember it's next to a minus sign, but this is a plus, so my center is negative 2, and then 3. And then the radius is just the square root of 1. And the square root of 1 is just 1. So cool. All right, let's do it one more time, just to make sure you understand the process. The first thing I'm going to do is I'm going to group my x's together, and then I'm going to group my y's together, move my constant to the other side. And then add 1 to both sides. That'd be 1. There's a formula that goes in that weird blank. That b divided by 2 squared. So I take 4 divided by 2 and square it. 4 divided by 2 is 2. 2 squared is 4. And then negative 4 divided by 2 squared, that's negative 2, times negative 2 is 4. What you do to one side of an equal sign, you have to do to the other. The left side is factorable. So I'm going to go ahead and factor that. That's going to be x plus 2 times x plus 2, or x plus 2 squared. This is going to be y minus 2 times y minus 2, or y minus 2 squared. And then on the right side, that is equal to 9. So now that's awesome. I could pull out my center and my radius. Oh, great. Your center is -2, 2, and your radius would be the square root of 9, which is 3. And now you can actually draw a picture of that too. You'd plot the point -2, 2, go north, south, east, and west, 3 units, poof, circle. Out of that big mess right there. So tomorrow, I might still do a couple of problems on the notes, but for the most part, it's a practice day. I think you have 5 problems like this for homework tonight. I wasn't trying to, give you a ton of drill and practice at this point. I just kind of want you to make sure the skill stays fresh for tomorrow. You only have the odds on the assignment sheet, and that is your last book assignment from me. The last time you might, if you're not a person who uses your book as a reference, that might be the last time you touch that book. So that's kind of exciting. Just think one more book assignment. And then tomorrow, like I said, is a practice day, so I'll see how that book assignment went for you. We'll allow a day for this to settle in, and then Friday we start reviewing for your final exam. Any questions? All righty.